Aerial real footage of Niagara Falls in slow motion. Niagara Falls, one of the most powerful and breathtaking waterfalls on Earth. Over 100,000 cubic feet of water rush over these cliffs every second. But here's a strange question. What if we tried to funnel all that water through a drinking straw? Sounds impossible, right? Well, let's dive into the science, the chaos, and the cosmic destruction that would follow. Animation: giant cartoon straw hovering above Niagara Falls. Overlay text: typical straw diameter, 7 mm, split screen, real footage of water gushing plus cartoon straw trying to suck it in. A regular straw is only about 7 mm wide. Compare that to the massive Niagara River feeding the falls. Trying to push the entire waterfall into a straw would be like trying to squeeze a mountain through a keyhole. If we built a giant dam with only one straw-sized hole, a tiny trickle would escape, while the rest of the river piled up behind it, until it overflowed or broke through with catastrophic force. Animation: water molecules moving through pipes. Close-up animated bubbles forming right-pointing arrow cavitation effect. Real slow-motion clip of cavitation in turbines. Here's where fluid dynamics kicks in. Water doesn't just flow endlessly faster through smaller gaps. At extreme speeds, the pressure inside the water drops. This creates steam bubbles, a process called cavitation. When these bubbles collapse, they can shatter metal pipes like tiny underwater explosions. Engineers designing ship propellers, turbines, and pumps fear cavitation because it can eat away steel like sandpaper. Animation: water accelerating through a narrowing tube. Overlay: speed of sound in water approximately equals 1,500 meters per second, cut to animation of water ignoring sharp pipe turns. Another problem is speed. Fluids can only accelerate so much before hitting limits, like the speed of sound in that fluid. For water, that's around 1,500 meters per second. At these speeds, water starts ignoring bends in pipes and slams straight through walls. That means even if we tried, Niagara Falls simply wouldn't behave inside a tiny straw. Calculator animation crunching numbers. Overlay text: flow rate, 100,000 cubic feet per second, straw cross-section animation. But let's crunch the numbers anyway. The falls pour out at least 100,000 cubic feet per second. Force that into a 7 mm straw, and the water would need to move at nearly 1/4 the speed of light. Yes, you heard that right. Water shooting out at relativistic speeds. That's faster than almost anything we can create on Earth outside of particle accelerators. Animation: water molecules stretching into plasma. Particle accelerator real footage. Bright flash animation right-pointing arrow simulating nuclear reactions. At such speeds, water stops being water. The molecules would smash apart into plasma, a soup of charged particles. Cavitation, boiling, and normal physics no longer apply. Instead, nuclear reactions would begin inside this stream. In short, you don't just get fast water, you get a miniature star blasting out of your straw. Animation: Earth with waterfall beam firing into space. Cut to simulation: Earth overheating, oceans boiling away. Dramatic sound design. The power output of this Niagara particle jet would rival all the sunlight hitting Earth combined. The heat and radiation would boil the oceans, scorch the land, and leave our planet glowing like a burnt rock in space. So yes, trying to drink Niagara Falls through a straw doesn't just break physics. It ends civilization. Back to calm real footage of Niagara Falls at sunset. Gentle background music. So, what did we learn? Waterfalls don't fit in straws. Cavitation destroys pipes. Relativistic water beams destroy planets. And most importantly, don't mess with Niagara Falls. Sometimes, The laws of physics are there to protect us from our own crazy ideas. Thanks for watching. Don't forget to like, share, and subscribe for more mind-bending science stories.